In this record, I will talk to you about how this height gauge sensor is working. So if you consider this height gauge sensor, okay, if I will take it to here, this gauge sensor, it has three inputs. That's the gauge sensor, height gauge sensor. It has three inputs. I10. This input is connected to I10 of the PLC, and it's connected to I11 of the PLC and I12 of the PLC. So now if this is my if this is my PLC, if this is my PLC input module, etc., and output modules, so then here it goes directly to, assuming here is the I1.0, I1.1 and I1.2. So then, so the gauge sensor, the height gauge sensor, has three outputs of it. They go as an input to the PLC. What these outputs are about? So one is called, the I10 is called height. So it's called height, maybe in blue, height, HGTH, that's the abbreviated this way. And the I11 is HTDC, high top dead center. High, the I12 is high bottom dead center, HBDC. Okay, so why do I need these three inputs, and how we use them to detect a bad and a good size? Basically, how this high gauge sensor is working. Let's go over a video and see it.
Okay, so here I put a thick part.
So I'm adding a thick part, like now your part is a thick, assuming you have thick good size and thin washer. Okay, there are three types. So first I have a thick part. So what you see, yeah, you see nothing. So let's go over it again. So first you will see you have a motor here. So here it's a motor, and this motor is creating torque, so connecting this disc. And if you look to that disc carefully, so now if I'm moving, so it's rotating in one direction always, because now I'm going backward. So but usually it's rotate in, and so here, okay, in this direction, as my torque is indicated, okay, in this direction, okay. So it's rotating in this direction. And two important things you can see. You have here a hole, okay, you see it, this hole is here, and you have another hole on this disc which is now opposite to it, somewhere here, but I will put it dotted because it is in the on this disc, so you cannot see it. Okay, so now it is here. Now look what I will do. I will rotate the motor in this direction, and this hole which is down, So in this disk, it is here now. It will move up to reaching some point, reaching here. Also, it's not seeing. You have another sensor here, opto sensor, infrared sensor. Okay. One is detecting the hole, then he's gonna light the BDC. Maybe you can read the BDC. BDC is bottom dead center. This will be lightened. This corresponds to this disk. When this hole is in between the infrared, so then the infrared will not be detecting an object, so then this will be lightened. And this hole also, because moving in this direction, when it is in here, when this hole is here, so the TDC, the top dead center, will be lightened. So now this is for the top. Okay, let's see it. So now we will rotate. So if you see the so you can see the hole. So the hole originally was here. So now I'm moving it. I imagine now, so in here you have the hole on this disk, which is connected to a BDC bottom dead center LED. Now it is up to here. So now here you have a dotted dashed circle which corresponds to this disk, a hole which is opposite to this one. So now when this disk becoming here, somewhere here, so the inner disk here, hole, will be here, somewhere here, and the BDC will lighten. Okay, so I'm expecting now very soon. You see, it's lightened, it's on. You see, it was off, it is on. You see, it is on because this is a bottom dead center. It is a hole on this disk. Okay, if you keep rotating your motor, this motor only keep turning on one direction, so then it will goes off. And what it means, bottom dead center? Bottom dead center means here you have a plunger that is moving. When you are rotating here, you are pushing the plunger down, and this is it's going down. So as I told you, you have here part. So this is the plunger, is moving down. It may touch until it touching. Actually, it will touch always the part. So what will happen? So now means the plunger, it's the minimum bottom dead sensor, mean it is at the lowest position of it. So now if you keep rotating, then the plunger will goes up again. Okay, so now it is at the lowest position. So if I keep rotating, so it's moving up. This plunger should move up, and until this hole will be in here, in between here, and therefore the TDC will go on. Okay, see, we are very close. Now we are here. So yeah, actually you see here it's very nice. Now I can see the hole which I was talking about, which is here. Okay, so you see opposite to it. Good. So if you keep moving now, in a while, so now it is here. After some time the TDC should go on. Oh, it is on. So you see the TDC is on. Means the plunger now it is at its highest position. Okay, the plunger now, this plunger is at its highest position. only at that time I opened my dispenser 1. Remember your dispenser 1. Only at this time I open my dispenser 1 and I throw a washer and I turn the conveyor 1 on. Okay, so first you need a pre-initialization step for your plunger, for your height gauge sensor measurement, because it may happen that the plunger is at its lowest position when the conveyor stopped last, and therefore if you have a washer that's moving, it may get in trouble because it's going to touch the plunger first, which should not be the case. So then we do an initialization process, pre-initialization process if you wish, in which we make sure that the plunger is at its highest position. So that's, now we are here, means we are at the highest position. Okay, so if it keep moving a bit for some precisement or because you need time maybe to hold to stop it, so it moved a bit just up, but still like it is at its highest position. So now we are sure that the plunger is high. So then I open my dispenser and I move the conveyor so it will transport my washer, and that's what's happening now. Okay, you see the motor, the HMDRV is off now. The motor that's creating a torque is off, but the conveyor dispenser was on. So I throw one washer and this washer will move. See, it's moving until it is detected by the system. Okay, once it's detected by the system, by this opt1, it is an opt1. Once it's detected by opt1, maybe you just need to wait the time it takes from here to here, maybe 1 second, the time it takes from here to the plunger, and after 1 second you stop your conveyor, so that you make sure that your washer is below the plunger, below the height gauge control unit. And what will happen next? So after a second the conveyor stopped. You see now the conveyor is stopped, is not moving at all, but the conveyor stopped and the motor is turned on. You see the motor is turned on. You see it was here at its highest position. At its highest position, start turning means start going down. The plunger start going down. Start going down. And what will happen now? Remember, this is a thick part. I was picking a thick part to test it. And what will happen? So you see now, I can see here two signal, which I didn't talk about. I told you have 3 inputs. So I was talking about the bottom dead center, and I was talking about the top dead center, and they are normally open. And I was telling you this is the top, corresponds to the top dead center, and this hole which is opposite to it from the other side, bottom dead center. But what are those? Those are an indicator, which here is written like two small part, and here is two big part and two small part. Just an indicator saying it's too small, too big or too small. Okay, but those are not an input. Your input is height. Okay, in addition to high BDC and high TDC. So what happened now? I'm keep turning. So now here is from behind should be your BDC. Moving up to, so you see this is still indicating it's too big, still too big, because I'm moving down, right? You are moving the plunger down. Now the plunger is moving down, but maybe the plunger now it hit the washer and it's not able to move anymore. So then still this light is always on. This light still always on. It's an indicator that it's too big. And if you want, also those are similar. They have an infrared sensor, and yeah, I didn't focused on it because I want to focus only on those. But anyway, so it's the same way principle. So then the plunger is not able to move anymore because it hit this way, and therefore it is in a position where it is called too big. So it's thick part. And even if you keep moving, so now you reach the lowest position of your plunger. Actually, the plunger reach its lowest position. What do we mean by reach its lowest position? I mean the plunger is already hit the washer a while ago. What we mean by that is the hole actually is here, and therefore we are completing a one full revolution. One full revolution from head high to head to the bottom dead center. And when in this full resolution, if I look to here, it's saying too big. So now if I keep moving, my motor, assuming I don't need to keep it moving anymore because I did one revolution, so it's alright. But assuming now I keep moving my motor on, so what will happen is the BDC will go or will go off, and the plunger will lift up again. Okay, will lift up again. But here is the one revolution, and if you look to both, and this is my point that I want to say. If you look to both LED, the BDC, and the too big, they are on at the same time. If they are on at the same time, means my part is too big. Then maybe you can have an indicator and a red indicator. Maybe and a blue indicator. Okay, and this indicator telling you it is good size. This indicator telling you it is too small, too good size, and too big. Then if you want to program the too big, if you have three lights that indicating this is a good size, this is, so then how to program it? If it is a big size, so what will happen is your BDC or it's called HBDC, and the too big will be on at the same time. Assuming here it's Q00, Q01, and Q02. It's an output you are taking yourself. So then here is Q01. Okay. Actually, it's the height. Okay, it's the height which you have it in your here. HGTH. Okay, HGTH as a height. So too big or too small, both are connected to HGTH. They are say giving one. So now this is one, you see it, and this is one, the HBDC. Therefore, my light indicator, let's say too big, will go on. You don't have a light indicator in your output field devices, but just here I'm assuming for you to tell you how you program the too big, and in the same way you program the too small. The too small, you will be programming it this way. assuming it is Q00. Here it will be the height GTH, and here will be height top. I said good size. Sorry, let me go to the too small. Too small. That's how you program the too small. H. Sorry. Let's program the too small first. HGTH and HBDC. So you program too small and too big, you program them the same way. And the good size, what is good size? How do we program good size? To program good size, you should have this one. HBDC. Okay. This is the Q00. This is the HBDC, and here is the height also. And it's not the height, it is the non-height. That's how you program good size. Anyway, you will see them. So here it's the too big, as you can see, 1 and 1. Okay, so now because they are, so then it is too big. So now you will see that at this instant the motor will stop and the conveyor will move, considering this part as a too big part. Okay, so let's see the other video.
So now
in which we will pick a thin part. So thin part to small part. Okay, so then in this case you will see that also this time not the too big, the too small and the HBDC are on. HBDC and the too small. Too small is height. Both of those, they are connected to the height. This or this, both are connected to the height in your PLC. So those two are connected to the height, which is I10, and the VDC is connected to I12, and the TDC is connected to I11. Okay, so let's see what will happen now.
I put a thin part.
So just to permit you see them clearly. So this is the initiation process as we did before, so we make sure that it will stop at the highest position. You see, highest position. So now what we'll see in this thin part, you see now we keep moving, so then we are actually now at the bottom dead center. Look what happens at the bottom dead center. The too small is on, at the same time bottom dead center. So then HBDC is on, and the height bottom too small also it's connected to the I10, to the height, and therefore 1 and 1 this will be light. So then those have the same instruction. Okay, so you cannot really make distinguish if your part is too small or too big. Just it is not in a good size, so then it is bad size. Unless if you go and take this one alone to an input and this is to another input. Therefore, in this way you can distinguish between too big and too small. But for our case, as this too small and too big are connected to the same input, which is height, okay, so then you cannot distinguish between too small and too big. But you can know it is a wrong size. Ourselves, we know it is it is too small, but the PLC will know that it is not a good size, not in a good size. And at this time we open the dispenser and we turn on the sorry, at this time we now run the conveyor. Okay, so what happens if the
And now I put
so now if we put a good size, as I said, a good size, you should have not high. Okay, because if it's a good size, so not too small, not too big, so then those two will not light, and therefore height will give you 0. Height will give you 0, so then non-height will give you 1. 1 when you are at the bottom dead sensor, so it means you completed full revolution, and therefore you have in a good size.
a good part.
Again, the initialization, we do 1 full revolution, and yeah, here is still the initialization process. So this is one. So we stop. You see, we stop at the when we make sure that our plunger is at the highest position. So at the top position. Why? Because so you see directly. Yeah, it is lightened, but maybe I'm unable to. But you can see the light. It's very quick. I'm unable to stop it at the light. You can see the light. When it's lightened, means you are at the top highest position. So now we launch a washer, so we make sure it's not gonna stuck with the plunger. And this is detecting that there is a washer coming. So what they will do, they will count for 1 second and therefore stop the conveyor and turn the HMDRV on. So now what will happen? While detecting the thickness, we need to complete 1 revolution. So now see what happens. So I reach 1 revolution, HPDC is on while both are still 0. So then means we are in a high OK, and therefore this is a good good washer, good thickness washer. Yeah, I hope you now understand how this gauge, height gauge sensor work. Same thing for the width gauge sensor is working. So also it has 3 sensors, but we are not connecting it to our PLC. In your simulation, if you wish, you can connect it to the PLC if you wish. Just doing simulation, so you can choose a PLC hardware in your simulation that has extra inputs, so you can use you can detect this kind of stuff. Okay, you can detect the width or the diameter of your washer.